Okay, we're looking at a set of problems that are going to serve as a basis for constructing your exam. Okay. So I'm just going to kind of summarize some of these problems and see how you think you might do them. And I'm not going to give you detailed, long drawn out explanations. So tell me, and you want to tell me quick, I need a thumbs up, thumb to the side, or thumb down. Would you know where to look in open math or in your text? Remind yourself how to do this? Think you would, yeah. Yeah, I mean, y'all have been doing the homework. Now, what I don't know is how much help you're getting online and stuff like that in doing the homework. So I get a pretty good idea by what you can do when you come into class. Some days it looks pretty good. Some days it looks like, maybe you got in a hurry and had a little about it. Okay. Or maybe it's just hard. All right. Well, that's up to you. You're the one who needs to learn it. And I think most of you are doing pretty well here. But anyhow, so to get a straight line through here, there are many ways to do it. I would suggest that you sketch a graph. Okay, so here's x equals 5. Let's say here's y equals -7. And you get the slope of 5/9. That means if you move over 9 units, you go up 5. So we have this point, and it's thinking ahead, would have labeled y equals -7 somewhere different. But I could still do this, give myself room here. Okay, I go over 9 units. How big is 9? Well, there's 5, so 9's probably about that big, so I go over about that far. I can even say run equals 9. Because this is the slope. This is rise over run. And then rise equals 5. Well, that would get me right up to the x-axis. Now, note that my scales are different. 5 units on the x-axis looks like it's bigger than 7 units on the y-axis, okay? So this doesn't have a realistic slope of 5/9. Still, you can sketch a straight line now through these 2 points. And estimate the y-intercept. If that's 7, that looks like about 10. If the y-intercept is at -10, and the slope is 5/9, use y equals mx plus b. M is your slope, b is your y-intercept, -10, right? Now, to get the thing exactly, you plug into y equals mx plus b and solve for b. You should know what to plug into. I'm not going to write it down, but I'll tell you. You're going to plug x and y coordinates for x and y. You're going to plug in 5/9 for m, and you're going to get -7 equals 5/9 of 5 plus b. You have a denominator in that equation, you multiply both sides by that denominator, and then it's really easy to solve for b. Okay? So, if you need to review what I said, that's fine. As I say, I can't take time to write everything down and work everything out. We're just trying to touch on the main things. Okay? Now, if we want a line perpendicular to this one through the point -6, 2, well, let's see, -6, 2. I'll use a different color for this because it's actually kind of a different problem, but there are problems that combine both of these things. I'm going to use yellow with my little contrast. So if 5 is here, -6 is probably about here. Okay, and it's -6, 2. If y equals -7 here, y equals 2, maybe about here. -6, 2. And then we want a line perpendicular to this. So a perpendicular line. Now, the question, where do these lines intersect? I have to repeat that somewhere else because I'm going to need this space. Sketching, which is what you do with this stuff. Okay. Slope is -5/9. As soon as you know the slope is this, and you know a point on it, you do the same thing we did up here. You plug into y equals mx plus b, you got m, and you got a y and an x, so you solve for b. Now, it helps to remind you of that if you actually draw the graph and make an estimate. It looks like the y-intercept. If that's -7, there's another 7. That'd be 14. It looks like y-intercept about -18. Now you plug this in, solve for b. Solve this equation for b, and then you have your equation for fine. So you multiply everything by 9, and you get 18, you get 9b, and you get 30. 30 minus, sorry, 30 plus 18 is 48. That's 9b, so it looks like I've got a bad estimate for the y-intercept, because I'm getting 48/9, like -5 point something. That's not right. So what did I do wrong? Let's see. Y-intercept is 2. Slope is -5/9. X is -6. 5 times -6 is 30. Multiply everything by 9, I get 18. I get 9b. Doesn't make sense. But that's what you do. That's how you do it. The b I'm getting doesn't match the b I estimate from a reasonable graph. Okay? B I'm getting is around here. Okay? Well, the problem is I don't have equal scales on the X and Y axes. Okay? So what I think is perpendicular isn't really perpendicular. If I'd set this up with equal scales in the X and Y axes, my estimate here would have been better. Okay. Now, scales on the graph work okay. If I solve this one, for x equals 5, I get 25. I get negative 35 and 10. I get 25. And it looks to me like the y-intercept really is negative 10. Okay? I'm sure. 9. No, I got that wrong. Okay, it's negative 7. And it's 25 minus 10 is 15. Yeah. Highest another y-intercept working great. Okay, still, doing the estimate is meeting your equation, and that's kind of a big deal. So I do recommend estimates. Okay. And estimates also kind of help tell you whether your solution is reasonable or not. Now, we've actually covered at least two things. The question of where do these lines meet? That's where we solve two simultaneous equations for two unknowns. Okay. So what if I ask the question, where does this line meet this line? First place, recommend you sketch a graph. Y-intercept here is -3, so let's put y -3 here. The slope is 4/7. So if we move over 7 units on this scale and up 3, we would have the y-intercept in this point, and that would be the graph. This line, the y-intercept is at yeah. Okay, I got started. I'm looking at these equations and not really looking carefully. I can normally get away with doing what I can't today. Same thing. Let this be y equals -3, which is what I intended. And then if we move over 7 and up 4, well, over 7 might be about here, and up 4 takes us up a little below the x-axis. And I have a line. For this equation, the y-intercept is at 6. That's 2. 3's there, 6 is about. There's the y-intercept. And then I move over 4. 7. So let's say that's over 7, that's about over 4, and down 7. That takes me just about to the line. Okay. I kind of doubt that I'm really on the line. But the lines would look like this. You can estimate the point of intersection, which usually won't be all that close to the line. I just made up these numbers without any regard. Okay. The exact solution is x minus 3 equals -7/4 x plus 6. Because the y coordinates have to be the same, I can set this equal to this and find the x coordinate. They meet. Multiply both sides by 28. which is least common denominator. And I get 28 times 4, which is 116. And 84. And negative 28 times 7 is negative 100. And 28 times 6, if I'm doing my arithmetic right. And that's times x. And then 6 times 28 is 140, 100 plus 168. So I get, well, I don't want to take time to work out the numbers. If I add these two, I think I get 312. If I add this to this, I think I get 252, 272. So it's 312. Okay. Now, you know that fraction, this numerator is a little less than the denominator. It's pretty close to -1. Okay. So the y-intercept is going to be, so that's x. So 12 is my solution. Anyhow, that's how you solve it. Again, we're just trying to skip. So if I want to find where these lines intersect, I sketch a graph and estimate, and then I solve this. Okay. Now looking at the concerns rational functions doing the algebra. So, for example, you might be asked, you might be asked to something like this. And what we can do is you factor the quadratic if possible. And in this case, it's possible. And then that equals, well, you're going to multiply the numerator. And you're going to multiply the denominator. So it's very simple, except now you want to reduce it to lowest terms. And this x plus 3 will divide this x plus 3. So that's just x plus 5 times x minus 1. You can check this by just picking a number out of the hat, preferably not 0 or 1 or -1, but maybe a small number like 3. Plug in x equals 3 and see what this equals, see what this equals, and multiply. And then plug in 3 for x here and see what you got. In this case, it's pretty easy. 3 and 5 is 8, 3 minus 1 is 2, so that's 16. 3 plus 2 is 5, so it'd be 16 over 5 if you picked x equals 3. If you plug x equals 3 into this, you should also get 6, whatever I said. It's 16 over 5. Okay. If you wanted to add, It might be hard to read, parentheses, it's almost that easy to start with. But we multiply numerator and denominator here by x plus two, multiply numerator denominator here by x minus three, and we see that we have the same denominator. Now we can express the whole thing with the denominator x minus three times x plus two. And I'll say it's 7. Expand the numerator. Simplify. Factor if possible. Simplify if possible. If you multiply all this out using the distributive law, multiply all this out using the distributive law, then you get something you might be able to factor. And one of the factors might be x minus three or x plus two, in which case that factor would divide out. So there you have it. And this is fairly challenging, but I think y'all are doing pretty well with it. Okay? Make sense? Okay. Okay, let's say you got AB plus C over D equals EF minus G. Solve this for one of the variables. Okay, probably the most challenging one to solve for would be D, so I'm going to solve for D. But it's not really very difficult. The reason it's challenging is nobody ever remembers to multiply by the common denominator. Okay? So if you're the exception, and hopefully everybody's an exception, and remember to multiply by the common denominator, whether you're solving for D or anything, your first step here really should be multiply both sides by D. And you get this. Now, how are you going to solve for D? I would divide both sides by the quantity EF minus D. This gives you 1, and now you have D. And I'll reverse the signs. D equals AB plus C over DF minus G. And you see that the only challenge here really is you got to remember to multiply both sides by D. You'll do all kinds of things. They just decide, well, D is easier if I put it in the numerators, I'll just put it in the numerator on this side. It doesn't work. It's not, you're not following the rule of algebra. The rules of algebra allow you to multiply, divide, add or subtract something on both sides. Okay? That's it. You got to use one of those rules. Same thing, both sides. All right? And, you know, Look through those formulas, think about how to solve each one for whatever variable. If you come across a problem that gives you an expression like that, probably be to your benefit to solve it for every one of those variables. Okay? So again, take that for what it's worth. Of course, I know you have limited time. Okay, so we got formulas. Now, what do we got? Problems with exponents. Typically, something like this. Okay, what would you do if you had that? Well, place, that's going to be x to the fourth y cubed over multiplied by the reciprocal. When you're dividing by a fraction, you multiply by the reciprocal. You understand why I emphasized in the beginning of the course the operations you do with fractions. You have to be good with fractions. And typically in a class like this, most people aren't good enough with fractions. Okay. And you see how it gets in your way when you're doing rational functions, right? You're adding, subtracting rational functions, dividing them, multiplying them. Okay, so you got to know division by a fractional expression or real expression, whatever it is multiplication by the reciprocal. Now I forgot my -2 exponent. Okay, -2 exponent means you've got 1 over x to the fourth 1 over z squared times y over x squared 2 to the fourth. That equals 1 over, you square all these, x to the fourth squared. Remember, you got x to the fourth times x to the fourth. That's what x to the fourth is. See right out, x times x times x times x, multiplied by x times x times x times x. And that would give you 8 x's in a row, which would be x to the eighth. And the rule, of course, is you just multiply the exponents. You apply an exponent to something with an exponent, you multiply the exponents. But to keep that rule straight, you need to understand why. Get this? Now, what do we do about this reciprocal? You're dividing 1 by this fraction, so you multiply by the reciprocal. Okay. Now you see you've got a z to the fourth in the denominator and a z to the fourth in the numerator. So that'll divide out. Well, let's write it out. And we can end up with z to the fourth divided by z to the fourth just gives us one. We don't do anything there. Y divided by y to the sixth is one over y to the fifth. And we have x to the eighth. An alternative way of doing this from this step no, we'll do this that way. We write everything out as linear as I can. X to the fourth, y cubed, z to the negative two, y squared, x to the negative two, z to the negative four. In other words, is it z to the fourth in the denominator isn't z to the negative fourth in the numerator because of our rule of exponents says a to the negative b is one over a. Okay, I'll even write that down. Know that. Okay, now this is to the negative two. So now we multiply the exponents to get x to the negative eighth, y to the negative sixth, z to the fourth times y squared, x squared, z to the negative fourth. We can rewrite that as to the negative eighth times x squared. To be really clear about what it means, times y to the negative sixth, y squared, times z to the fourth, z to the negative fourth. This then equals x to the negative eighth plus two, y to the negative six plus two, z to the four minus four, which is x to the negative sixth, y to the negative fourth, z to the zero. Z to the zero is one. That's the last something. Okay, I made a mistake up here. It should have been x to the negative two. So that should be 8 minus 2. So that should be x to the negative 10th. You see where I had an x to the negative 2 here, but then I didn't put the negative on the 2 here. You want to be careful about that. It's like I'm not. Okay. And then when I did this step, I didn't write my square on the y. I a y² y to the 6th, which is y to the 4th. And now it agrees with what I have here. Steps x to the 10th is x to the 8th times x² is x to the 10th. This equals 1 over x to the 12th y to the 4th. Now, I took the time to work all this out and check first to make sure I did this right, and I didn't. Okay, had a couple of careless errors. You're likely to have careless errors too. It wouldn't hurt you to work it out both ways. In addition, there are problems that ask you to express the result with no negative exponents. That would be this one. Okay. And then express it with no denominators. Denominators here. Okay. And you have to use negative exponents. Well, you need to understand those groups for exponents. I recommend you give them some attention. Because they're usually a stumbling block for pre-calculus students. Is that camera in focus? No, I don't think it was in good focus. And I've kind of done this, but I'm gonna kind of do it again. Okay. So straight line 357 that's perpendicular to this line, and another line that's parallel to this line. So we're going to start with a graph. We have the point 57. And if this is 5, it's plausible that this is 7. Maybe even further up a little higher. Okay, so we're going to go through this point. We want it to be perpendicular to this line, parallel to this line. First of all, let's do the line 3x plus 5y is 15. Or 3y plus 5x is 15. X-intercept occurs from y equals 0. So 5x equals 15, x equals 3. So we have here at x equals 3. And then the y-intercept is equals 0, so 3y equals 15. Just squeeze that in. I shouldn't have to write it out. Y is 5. So we can label these 7, 1, 5, 7. Okay, I'll label this here. This is the point 3, 0. This is the line 1 equals 5. This is the point 0, 5. Here's the line. Now a line perpendicular to this one through this point is going to look like this. It's going to be a right angle. And it looks like my y-intercept intercept the perpendicular line is about 0, 3. If so, The slope would be what? This point. This point, we have to go over 5 units. Go from this point up. Be up to 7, we have to go up 4 units. The slope is rise divided by run. Rise is 4, run is 5. Now this is all by an estimate from the ground. So I'll say y approximately equal to 4 pi x plus 3. Make sense? It should. Here, this is worth taking a good look at and understanding because it tells you a lot about straight lines. Okay. Then we could sketch a line parallel. Here's your parallel. Something like this. It's kind of vague, and it looks like the y-intercept is way up here. If this is 5, this is 10, it might be close to 15. Two parallel segments like this stand for the word parallel. Okay, parallel line. Estimate the y-intercept. You know, doing this. These end of the semester. Slope of the perpendicular line is -5/4. Negative reciprocal. Y-intercept is it maybe 0? Sorry, yeah, 0, 14. Slope is 4/5. Again, this is by estimate. Y is approximately equal to then if x plus 15. Dude, continue this. Regular line. Slope -5/4 through the point 5/7. Y equals mx plus b. There's your slope. There's an x and a y coordinate. So you get 7 equals -5/4 of 5 plus b. Multiplied by 4, you get 28 equals negative 25 plus 4p. And again, you get something that doesn't make sense. What's going on here? Doesn't make sense in terms of the picture, but it must be right. X is 5, Y is 7. Well, everything by b by 4. 4 times this is this. 4 times this is negative 25. 4b. Yeah, definitely. So we get b. Well, when I wrote down slope 5/4, I was wrong. Where do you think I got that from? The slope of this line is what you get when you solve for y. Write that out. If you solve for y, you solve put the x on this side, you get y equals x plus 5. So far I use negative 5/4, that's not right. The slope is negative 5/3. So this line has slope negative 5/3. So got that 5/4 out of something I saw earlier. Slope ought to be positive. Because the perpendicular line has negative reciprocal slope. I did the negative reciprocal of 5/4, which is a slope I used half an hour ago. Okay. I didn't calculate the slope of this line. So in order to see what slope to put in here, you have to find the slope of the original line, solve for y, and then use the negative reciprocal. So the only thing I have to change here which I wrote down in the again, this is your perpendicular line. The slope of the original line is negative 5/3. So the slope of the perpendicular line is plus 3/5. negative reciprocal. And this ought to be 5/3. The slope of the parallel line is the same as slope of the original line. So if let's redo this. Okay, slope is negative 5/3. Else is 3/5 through this point. Y equals mx plus v. Replace y with the y coordinate, which is 7. Replace m with the slope, which is 3/5. Replace x with 5. There we have it. And now we do just what we did previously. We multiply both sides by 5. I'm not going to write out the entire step, but we're going to get 35 equals 15 plus 5b. So that's an easy equation to solve. So I'm not going to go through the steps. You understand what's going on? Make sure you do about parallel and perpendicular lines. Point to this example is this isn't in slope intercept form, so you just can't read the slope. You have to do what I didn't do, which is solve the equation for y and get slope intercept form so you know what the slope is. So the slope of this line is negative 5/3. Now you could figure that out. You've got the x-intercept at 3, 0 and the y-intercept at 0, 5. You get from here to here, you go down 5 and over 3. That's a rise of negative 5 and a run of 3. Giving a slope rise over run is negative 5/3. Then using this information, we estimate the y-intercept for the graph. We estimated that the y-intercept was at 0, 5. Then we plug the actual numbers into the equation y equals mx plus b, the slope that we found for this equation, and doggone it. Yeah, no, the perpendicular line slope is 3/5. Okay, so we plug the slope of the perpendicular line in for m and the coordinates of the point, and we solve for b, we get b equals 4. So the y-intercept at 0, 4. Whereas the estimate I made here was 0, 5. Okay. And the point of that is now doing a careful graph. I can check out my solution. If I find that everything is haywire and doesn't make sense, which would have been the case with the 4/5 I had there, I had to go back and find my error. All right, then the parallel line. Slope is negative 5/3. Five, 7. Y equals mx plus b. We get 7 equals negative 5/3 x b, and x is 5. And we multiply both sides by 3, we get 21 equals negative 25 plus 3b. And that gives us 46. B equals 15 1/3. So the y-intercept would be at 0, 15 1/3. The estimate I made from this graph was 0, 14, I think. Okay. Now, having found the y-intercept, I can write the equation. It's 3x plus 4, the perpendicular, 3/5 x plus 4 for the perpendicular line, which compares y equals 3/5 x plus 3. And I wrote the y-intercept as 0,3, which was a mistake. It's 0,5. So my estimated equation would have been 3/5 x plus 5. My exact equation is 3/5 x plus 4. Okay. Then here, y equals 3/5 x plus 15 and a third. Negative 5/3 x. And slope is negative 5/3. So my estimate was negative 5/3 x plus 15. It's actually y equals negative 5/3 x plus 15 and a third. So now I'm convinced that I fixed my mistakes. Okay. So if you view this part of the video, make yourself a note. And I made some mistakes. Okay, I wrote down some things carelessly. And try to catch them. But the process is just what it is. Quickly, there's just a couple more topics here. We can dispose of them pretty quickly because they're topics we've done recently. Um, this times x plus 2 is this times x plus this times 2. We get x cubed plus 4x squared minus 3x plus 2x squared plus 8x minus 6. We have an x cubed. We have a 4x squared and a 2x squared. We have a negative 3x and 8x, which gives us 5x plus 6. You're pretty good with the distributive law, just make sure you, okay. Then factor. Nine x squared plus 6x plus 3. Well, and I'm going to make out x cubed and x squared plus 3x. Factor out 3x because 3x divides every one of these. And you get 3x times 3x squared plus 2x plus 1. And then you factor this. This is going to be 3x plus a number. This is going to be x plus a number, because the only way to get 3x squared with integers is for multiply 3x by an x. Now, when I wrote this down, it's 3x there, but give us a minus. So now, plus 1 here and a minus 1 here. So, a minus 1 here and a plus 1 here. Then when I multiply this out, I do get 3x squared. I get minus 1 times x plus 1 times 3x, which is 3x minus x, which is 2x, and so forth. And in fact, now we've been over the factoring to be sure you review. Okay. And then the last thing that I'm not going to take time to go over, partly because we're out of time, partly because we just did it 2 days ago, is quadratic formula. And y'all were pretty good with that last couple of times. So I don't think you have a big problem with that. Now, doesn't mean there won't be other things on the test, but if you get the things we just went over, you'll certainly come up with a passing grade. Okay. One thing I didn't go over and that you do know is going to be in the test, though, is the graphing stuff we've done within the last week. Okay. And the function notation. So be careful about that. Just review the class from last week, or the classes from last week. Review what you did for your homework. And if you have questions, bring them to me or email. Okay. Give you a good answer. Fair enough? Okay. Y'all have worked hard. Hopefully, you've done it in such a way that you bring it together and pass the test and pass the course. Okay? And if you happen not to pass the course, I would recommend that you take it again. But you also would have the option of signing up for the support course for pre-calculus. I don't recommend you sign up for both the support course and pre-calculus unless you pass this course with a pretty solid grade. Okay? You could do the support course and then do the pre-calculus. Does that make sense? And that's not supposed to be possible, but it is. So don't let anybody tell you you can't do it. If they do, just email me. I'll double check with our director of admissions. But I'm told that that's perfectly feasible. Make sense? And okay, well, I hope to see everybody in the support course, unless it's to your advantage to repeat this course. Okay, because somebody started out, pretty deficient background. Okay. Maybe it's because it'd been a while and stuff. And it could be a stretch to do basically an Algebra 2 course, which covers a year in high school, in a compressed semester. So don't feel any shame if you don't make it, but do your best, work hard, try it. And most of you, I think, are going to be able to do it. And hopefully everybody's going to be able to do it. Okay. So y'all have been a great class. I've really enjoyed working with you. And hopefully I get to work with you again in the support course. Okay.